In the previous tutorial, I worked with the TRK Neo 500 mobile scanner data and demonstrated a lot of tools that could help you to digitize your site and extract all relevant features. If you didn't see it, then go to the below link. In today's tutorial, I would like to continue working with the mobile scanner data from Pegasus TRK and try to create my own rally racing map based on this data for the BeamNG.Drive. So the first step in processing Leica mobile scanner data is Pegasus Office. It's very friendly user software that allows you to calculate trajectory, combine different tracks, generate a high-resolution point cloud, georeference images, and the most useful feature for us is automatic classification of the point cloud. The software can determine more than 20 different layers in the point cloud and export all data separately by layer. For the digital terrain model creation, we will use the below layers. If you're working with the point cloud that wasn't split by different classes, for example from the terrestrial scanner, then you can run the auto classification tool directly in the Cyclone 3D and select the auto type for classification. The classification process is based on machine learning algorithm that relies on GPU computation, and it can determine the surface very precisely with any type of point cloud. For the Pegasus TRK data, select all three layers with surface point cloud and import them into Cyclone 3D. Next, just select all of them and merge in one single layer with the group button. Then click the Scan to Mesh button. In the settings, select the medium quality. It will be enough to keep all details and get not too much triangles, but you can choose other settings based on your requirements. This command creates a texture mesh from a cloud by segmenting in boxes. When the mesh will be created, select it and change the representation mode from textures to smooth. You will see your mesh has two colors, gold and blue. It will give you an understanding of how the normals look. A normal in 3D modeling is a depiction of the orientation of a polygon surface. The gold color means the outside of mesh, the blue color means the inside. For the BeamNG, all visible parts of the model should have a golden color or be reversed as an outside surface. To do that, select mesh, click with the right mouse button and choose the ungroup in the pop-up window. After ungrouping, you will see that all parts will have different colors. Select all of them and assign the gold color to them with the right mouse button. Select it in the pop-up window menu color and choose gold. Next, select all blue parts of the mesh and reverse them with the right mouse button. Click the reverse button in the appeared window. With Cyclone 3D, we have different options for how to improve our mesh surface, but before that I recommend you to stitch it, because after the Scan to Mesh tool we get a lot of mesh segmented by boxes, and tools with filling holes don't work correctly with it. Select all parts of the mesh and click the Stitch Mesh tool. Overlapping areas between two meshes will be identified according to the tolerance distance, and the meshes will be connected with a clean mesh in the overlapping areas. After that, we can reduce the number of triangles to make the surface more light. Select it and click the Reduce button. This command simplifies or reduces the number of vertices of the selected meshes and applying an overall reduction. There are two methods of reduction: control the deviation and keep the aspect. You can play with different settings to get the best result. Use the Fill Holes tool to fill or modify the free borders of the selected mesh. Select the holes you want to fill. Select holes are displayed in pink. Click Preview. The triangles are built in prolongation of the free edge to fill. Try to use different options such as add points inside holes and prevent self-interaction to get the better result. Improve the border of the road with the Smooth Border tool. This command modifies the borders of the selected meshes. The borders will be smoothed. If your holes have not close contact, then the tool will not help. Use the Bridge tool in that case. The command is used to make bridges to separate big holes into smaller holes, which are easier to fill with curvature continuity using the command Fill Holes. If your surface have some unwanted triangles, you can improve them with the Local Smoothing tool. This command allows you to smooth local parts of a mesh with a brush. Also, you can use Replace a Part tool. This command deletes triangles and vertices inside the zone and replaces these local areas with a new smoothed mesh. If you want to add some sharp edges to your mesh, then first you need to create polylines, which will be used to reorganize the triangles. Select your mesh and polylines and click the Sharp Edges tool. The meshes will be locally modified and stretched to pass through the polylines. It can replace rounded edges, fillets or chamfers. Sometimes could be helpful just to delete redundant triangles on the border of the road that are stuck too much from the main surface. Extract the external contour, apply the offset tool on it, and then use the join to contours tools. This command creates a mesh from two contours. You can adjust tangency and surface curvature. It will let you easily create the surface in that area where you don't have enough data. After all manipulations, check your mesh with the check integrity tool. This command detects integrity errors on the mesh and offers the option to correct most of them. After editing, the surface textures will be destroyed or corrupted. To fix this, select your mesh and remove the existing texture with the Remove Texture button. Then select Mesh in Point Cloud and click the Texture Mesh from Cloud button. This tool uses the colors from Point Cloud to add a texture on the mesh. Optionally, set the maximum distance. It defines the threshold above which the closest point of the cloud is rejected and will not be used for texturing the face. For building, we can use different kind of approach. I decided to create manually a simple shape of each building because a lot of walls are covered by trees and creating nice triangulation from this data is not possible. For the same reason, I didn't use here building extractor tool, but in some other projects we can use this tool. The main goal here is to get a very simple shape for each building to get a similar to reality visual representation and at the same time not overload our computer. So I use Cyclone MODEL to create all buildings and fences because this software has a lot of tools for auto-fitting different elements into the point cloud. And from the segmented point cloud layers, I took the below layers. When all elements are done, we should transfer them to Cyclone 3D via DXF format. While importing the 3D model to Cyclone 3D, I choose the force unit option to keep the right scale. You can create this sample model in any other software you like and copy them into Cyclone 3D. It supports many popular formats like OBJ, FBX, DWG, IFC, STL, JLB, IGES and others. Next, we need to check that all elements have the right normals orientation and ungroup it and colorize it to gold color, then reverse all blue elements in the same workflow as with the road surface. The next step is to colorize all buildings to real color. For that we can use the data from Pegasus TRK exported in E57 format. This format allows keeping panoramic images, so when we bring it to Cyclone 3D we can disable the option for importing clouds and leave only panoramic images. To colorize the mesh, select it and some images. Then launch the Smart Texture tool. The mesh will be textured based on the closest selected images, and sometimes sidewalls could be colorized from the wrong panoramic. To fix this, select Mesh and run the Adjust Texture tool. Choose the Remove Current Texture mode and fence the triangles which should be modified. This tool will erase the texture information from them. Next, click the Explode by Texture tool to split the mesh on different surfaces based on the texture information. Now select the required part of the mesh and panoramic images which you want to use for texturing and apply on it Smart Texture again. Repeat this workflow again if you will be not satisfied with the result. Also, optionally, you can select other surface objects and use them as an obstacle. They will filter images and thus the corresponding images won't be applied locally to the mesh. Before exporting all models to other software, I recommend you to set the coordinate system somewhere in the middle of your scene because not all software can work with big coordinates. To do that, just run the Define UCS tool in the period window, click plus symbol and specify the place where you want to move the origin of your coordinate system. Then export all models to GLP format. Keep the option Export in current UCS and leave meters as units of measurements. Import that model to the Blender with the standard option. After import, check that all normals have the right direction. Go to Overlays menu and select the Face Orientation option. You will see two colors. Blue will be visible in the game and red will be hidden. To change the orientation, select the object and switch to Edit mode. Select faces that should be reversed and click Alt-N on the keyboard. In the period window, click the Flip button. In Blender, we have option to adjust the texture of our objects. For that, select the mesh and switch mode to Texture Paint. Use the Clone tool to copy the colors from the specified area to the active location. Set the reference area with the Ctrl and left mouse button. And next, just move your left mouse button over the area that should be modified. Change the radius of the cursor and strength parameter if it will be required. You can repeat the same workflow for buildings and other elements. When your model will be ready, export it to DAE format, but create a separate folder and save all files there. Choose the global orientation option and leave Z as the default up axis. Next, let's move to the BeamNG.Drive. You can buy it and install it via Steam platform. After installation, go to this folder. Here you can see all available levels by default. We can choose any of them to start building our map. It's easier than creating the new level from scratch, because these levels already include some basic elements like trees, poles and other static objects. You can try any level you want. Open the archive file, go to the art shapes folder, create here a new empty folder and put there every DAE model that you exported from Blender. Run the game and select the same level in which you put the DAE models. When the level will be uploaded, click the F11 button to switch to World Editor mode. Click the window Asset Browser tool. In the period window you will see the percentage of loading assets. Just wait until it will be fully loaded. After all assets will become visible, find the folder with your models, select it and drag and drop it somewhere into your scene. Use the standard translation and rotation tools to place your model into the desired areas. To be able to interact with the model, you should apply collision on it. For that, select it and in the Inspector tab, choose the Visible Mesh mode for the collision type and enable option Pre-built collision data. After that, save your level and restart the game. Open again the same level, click F11 to open the World Editor menu and move the player car on the road which you added just right now. Click F11 again to close the World Editor menu, and now you can test your model. Use arrow keys on your keyboard for movement. The car will interact with your surface and you can simulate your virtual driving in real environment. Repeat the previous step for the other elements. Next, you can add some repeatable objects like poles, signs or traffic lights from the standard library assets. For adding vegetation, use the Forest Editor tool. It also has preload models of trees which could be easily placed on your surface. Use the point cloud as a reference to place them, and when everything will be done, enjoy the game. I choose the BeamNG.Drive as an engine because it has the best realistic physics I've ever seen, and it has a lot of tools for recreating the movement of vehicles and simulating cars. These engines could be very useful in combination with forensic software for investigation car accidents, especially if you're working with reality capture data. You can use data from the mobile or terrestrial as a scanner to analyze and investigate the car crash scenes in Map360 software. Point cloud gives you the most informative data about the forensic scene, and the software allows you to calculate a variety of crash reconstruction formulas like speed, deceleration factor, kinetic energy, momentum, kinematics and more, so you can use this information in BeamNG to recreate hyper-realistic crash scenes and make your reports more informative. For me it was also interesting, can I drive a rally racing car in that environment? So let's see what comes out of it.
Looking for a better way to get up out of bed instead of getting on the internet and checking a new hit. Me get up, first shot, hip strut walking, a little bit of humble, a little bit of cautious, somewhere between like Rocky and Cosby's for the game. Nope, we all can't copy yet. Bad moonwalking, and this here is our party. My posse's been on Broadway, and we did it all way. Chrome music, I shed my skin and put my bones into everything I record to it. And yeah, I'm on, let that stage light go and shine on down. Got that Bob Barker suit game and Plinko in my style. Money, stay on my craft and stick around for those pounds. But I do that to pass the torch and put on for my town. Trust me, on my INDEPENDENT shit hustling. Chasing dreams since I was 14 with the 4-track bustin'. Halfway across that city with the back crush shit. Labels out here, now they can't tell me nothing. We give that to the people, spread it across the country. Labels out here, now they can't tell me nothing. We give it to the people, spread it across the country.
Here we go back, this is the moment. Tonight is the night, we'll fight till it's over. So we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us. Here we go back, this is the moment. Tonight is the night, we'll fight till it's over. So we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us.
Nah, can I kick it? Thank you, yeah, I'm so damn grateful. I grew up really wanna go fronts, but that's what you get when Wu-Tang raised you. Y'all can't stop me, go hard like I gotta eat it in my heartbeat. And I'm eating at the beat like it gave a little speed to a great white shark on shark week. Raw, time to go off, gone, deuces goodbye. I got a world to see, and my girl, she wanna see Rome. Caesar make you a believer, nah, I never ever did it for a throne. That validation comes from giving it back to the people. Now, sing this song and it goes like, raise those hands, this is our party. We came here to live life like nobody was watching. I got my city right behind me. If I fall, they got me. Learn from that failure, gain humility, and then we keep marching.
And we go back, this is